Hello everyone, thanks for tuning in to my short video. This one's about stress and some of the terminology that I found confusing as I made the transition from doing purely structural geology through to doing geology, seismology, and geotechnical engineering. So let's remember what stress is. Stress is formally a tensor quantity. The units are force per area. And in contrast, strain is dimensionless, typically a change in length or change in area or change in volume divided by the original length, area, or volume. So the picture shows a scuba diver, and that's a good way to get an idea of magnitudes of stress. If you do scuba diving or free diving, you know that 10 meters of water is about the same as 1 atmosphere of pressure. So you go down 10 meters, you're at double the pressure you are at the surface, because at the surface you've got that huge column of air above you, but it's not as dense as water. And all that air above you is about the same as 10 meters of water. So in mining and underground, we of course deal with hundreds of atmospheres. And the other units that we commonly use in mining are megapascals, or MPa. So I also like to keep stress and strain terms separate and clear in my mind, and I think the terminology and being clear on that helps. So I use words like compression, tension, pressure, shear stress, normal stress to depict and talk about stress, and in contrast I use words like shortening, extension, contraction, convergence, shear strain, simple shear, and pure shear to talk about strain. So one thing I found confusing, but it's another topic, is strain bursts in mining. Well, okay, we'll talk about that another time, but it was confusing. So going on to the common geotechnical usage in mining, what's typical is to normalize the stress with the rock strength. So the question that's being convolved into the definition of high stress or low stress in geotechnical engineering is how high are the stresses, but relative to the rock strength. So common normalization strategies are shown here, and I've seen both of these as well as others. Typically, you might use the unconfined compressive strength, or UCS, to normalize the stress, and you might normalize the differential stress, or something like the mean stress or the confining stress. So why is that confusing? Well, in rock mechanics, if you look at the way to depict the stresses, we have down here the Moore diagram, the shear stress versus normal stress, and two states of stress are shown by the purple and light blue Moore circles. So that's a three-dimensional Moore circle, three principal stresses. The cubes on the right show the resolution of the stresses into the principal stresses. That's worth a review if you can't remember. But in any case, the purple state of stress has a higher mean stress, which is basically the center of the largest circle. And it also has a higher differential. It also has a higher mean stress, which is the average of the three principal stresses. I think I got that wrong at the beginning. But anyway, the definitions are here. So the comments, again, there's mean stress and differential stress. The geotechnical definition, I think, can be confusing because it simply names the stress as high stress or low stress conditions, but getting to whether you've got high stress or low stress conditions also depends on the rock strength. And then remember, if we see rock failure, like collapse of a mining drive, or dog earing, or breakout, or fracture in the walls of something, it could be that we have the failure because of higher local stresses or stress concentrations, and it could also be because we have lower strength. So if we have two different rock types in the hanging wall and footwall and a drive going along them, and they have different strengths, and we get failure on only one side, it could be a strength thing, not a stress thing. So remember, in practical terms, we want to use strength, the failure criteria, and the stresses to make a prediction. And I suggest as geotechnical engineers, we should be clearer in this space, and in particular, remember to explain this to other people who don't know the common terminology of high stress versus low stress in the geotechnical world. So thanks for that. Thanks for tuning in. Cheers. Bye for now.